Explore geometric sequences and series with applied examples. Master key concepts effortlessly.
Series, then practice with an application problem. This concept is also essential in the IB Mathematics AI course at the standard level. To begin, let's explore the fundamental ideas behind geometric sequence. Geometric sequence is a series of a non-zero number where each term is obtained by multiplying the previous term by fixed number called the common ratio. For example, the sequence 2, 6, 18, 54 illustrate a geometric progression with a first term of 2 and the common ratio is 3 because as you see each term multiplied by the number 3. The common ratio can also be determined by dividing any terms by the preceding term. For example, the second term divided by the first equal to third term divided by the second. That will yield us the ratio of 3. The next, we will use the n-term formula, which is especially useful because it allows us to find any term in the sequence without listing all the preceding terms. For instance, if you want to find the n-term of the sequence, we substitute the first term and the ratio and the n equal to 10 into the formula, and we will obtain 3 times 10 minus 1. And using the calculator, and we will obtain 39,366. And finally, we will use a specific formula to find the sum of the first n term of geometric sequence. This enables us to calculate the total of a series without having to add every term manually. For example, let's find the sum of the first 10 terms of the geometric sequence after substituting the given values into formula, and we will have, let's use a calculator. 2 times 1 minus 3 divided by 1 minus 3, and we'll get 59,048. Now, let's put this understanding in the practice with an application problem. An IB mathematics student is tracking the growth of a rare strain of bacteria. The population follows a geometric progression. On the third day, the population was 500. On the fifth day, the population had grown to 4,000, 4,500. So let's underline the givens. On the third day, the population was 500. On the fifth day, the population has grown to 4,500. So we need to find the common ratio and the first term of the geometric sequences. Okay, we know the population on the third day is 500. So we can have our first equation as follows. And if we simplify it, and the population on the fifth day is 4,500. we simplify these equations, we get dividing the second equations by the first equations will give us r square equal to 9. Since the population is growing, we take the positive root, so r will be equal to 3. To find the u1, we recall one of the equations. Let's call the first equation 500 equal u1 r square. And we know that the common ratio is 3. So we get u1 equal to 500 over 9. And that is about 55.6 in 3 significant figure. In part B, we're calculating the sum of the first 7 terms of the geometric series using the formula for the sum of the first n terms of a finite geometry and with a ratio of 3 and the first term of 55.6 is in part A. And after substituting the values into the formula, and we get 60,770.8. So if we give the answer as a 3 significant figure, and we get the population of 60,800 after 7 years. Thank you for watching this video on the geometric sequencing series. Save this video for quick reference and don't forget to subscribe and check out my other videos on my channel.